All right, here's another type. The key with this is just to get used to the strategy and get used to determining which, what are your factors and what do they entail. So if we look at these factors here, we'll see that we have a repetition of factors and then we have this one. So meaning that we're going to have three factors here or three roots. Okay, so here we're going to say that we're going to also check this is polynomial with a degree of 1, of 2, and this is going to have 1, 2, and 3. So this is okay. So what does this entail? This has been reduced fully, that has been reduced fully to its root. So we can say now that we're going to have three portions here. So one is going to be like this. The next is going to be B over this one. I think you should remember how we split this. And then the last one is going to be C, but this time around, we are going to have a square of the root. Okay, so now the next step is to simplify the side. Here we wait, because the only thing we use here is this portion here. Okay. Then, so we're going to have same denominator as this side. That is what helps us to say the top portions are the same. Okay. So we're going to say this, and then we're going to have here A, okay, this into there is 1, then we have this coming and multiplying with A, okay. Then we have the middle part. The middle part is x plus 1, meaning that we just get rid of 1 here, okay. So we're going to have x plus 1, like that. It will remain here, and then we'll have x plus 2. Then for the final factor, we're going to have this into there. It will leave us with this one only. So C is going to be x plus 2. Right. So we go on and make sure, because of space, I'm going to cancel this area. So this and that, they go because we're equating. And then this top part will equal to the other part here eventually. But then, because of space, let's just use this portion for now. So we expand this. This is a square of factors. So we know that it will give us a sum there and a product of 1. Then we go to this one. What will it give us? It will give us B. But then here we'll have x squared. Then we know that the factors here are going to give us 2x and x. So we'll have 3x and then plus 2. Okay. And then the final portion is going to be x plus 2 still. So the next step now is to put the factors with it. We could go on and expand everything first and then put the like terms together. That is normally the way that it's supposed to be done, maybe in an exam and all that. But here we know what we're supposed to do. So we're going to choose all factors that are going to give us the same variable. So here we'll have x squared, we just have 2. So we multiply ax squared, bx squared plus bx squared. Okay, that will be our first portion. Okay, that will be our first portion. Okay, and we're lucky everything is adding. Okay, then we go to the next portion that is going to utilize the x, okay, variable x. So what are we going to have? We're going to have ax, actually 2ax. Okay, 2ax, and then we're going to have the next one. From here, we're just collecting 1. So we're going to have b plus b, and you see we're multiplying here, so it's going to be 3bx. Okay, can we get x here? We can, so that'll be plus cx. You'll see it to be like this. Okay, then we go for the final portion. Final portion is also going to be addition because we don't have any negatives here. So it'll be a, we get a from the first one. If we get from the second one, it'll be 2b. Okay, we get from the fourth one, from the third one, sorry. So here it's be 2b, and the third one will give us 2c plus 2c. Okay, so already we can see that we're going to simplify this by factorizing. So we'll have a plus b x squared plus, here we're going to have 2a plus 3b x plus c, okay, x, then plus, this one remains as a constant, just like this, a plus 2b plus 2c, like that. Then we equate to the first portion here, okay, the numerators, we equate them. So this is going to be x squared. Now we don't have variable x here, so it will be 0x. Then we can say plus minus 2, okay, given that this is negative and everything here is adding, so that they are similar, right? So now we'll have three linear equations here. A plus b is going to be equal to the coefficient here, which is 1, then 2a plus 3b plus c, okay, equal to 0. Then we'll have the last portion, a plus 2b plus 2c equal to minus 2. You can see that this is a simultaneous equation. If you remember, this will be the arrangement that they normally give you, where they say this is equal to 1, and then here they will say 2a plus 3b plus c equal to 0. Then we have a plus 2b plus 2c equal to minus 2. So then we solve for this, and then we will create our partial fraction. But we have a number of series where we solved simultaneous equations. So if you're in doubt, you can go and see those, but I'll present the answers here. Okay, so now we see that a is 2, okay, b is minus 1, negative 1, and then c is negative 1. So how do we put this back into here? Okay, how do we put them back here? So we have to be careful. So let's do it from here. So a, we're saying, is 2. So this fraction becomes 2x plus 2, right? Then what about the middle part? The middle part has got minus 1, so the whole structure can be turned into a negative. So 1 over x plus 1. And what about the last part? It's also negative. We can say minus 1 over x plus 1 squared. Okay, so this makes it easier for you to apply other concepts of mathematics. Okay, could be maybe you're trying to integrate. Now you integrate that one, you do this one, you do this one. Or could be that you're trying to differentiate, depending on what they give you. So this is why we actually need to have the ability to form partial fractions. So this is the partial fraction that we obtain from decomposing this rational expression. Okay, all the best as you go through.